All right, page 2 is about what happens when you have two terms and you're trying to factor. So in two terms, the most popular way to factor is, of course, the difference of squares. Remembering that the word difference means to subtract two squares, a squared minus b squared. There's a pattern here. It's a plus b times a minus b. So it gives you a very functional way to look at something and just say, I have two things that are squared. I have a 5x squared and I have a 9 squared. So I can make that 5x plus 9 times 5x minus 9. So when we look at our examples, we have 16x squared minus 9. 16 is 4. So we have 4x plus 3 times 4x minus 3. We have a 144 is 12 squared, so plus 12b, and a minus 12b. I have r plus 4 quantity squared minus q squared. So I have r plus 4 plus q, and I have r plus 4 minus q. It's a little trickier when the parentheses are on the other side of the minus, because we have b plus 2g minus 1, and we have b minus 2g minus 1. So we have to remember to distribute b plus 2g minus 1 times b minus 2g plus 1. We have x squared minus plus 4 times x squared minus 4. The x squared minus 4 is still the difference of squares, so we have x squared plus 4 times x plus 2, x minus 2. So if you can factor the second set of parentheses, you have to continue factoring. X squared plus 100 does not factor. The plus is not a minus. We cannot factor the sum of two squares. And that is page 2. I'll see you on page 3. Actually, let's just go do page 3 right now. Page 3 has two parts, the difference of cubes and the sum of cubes. Big difference between squares and cubes is that they're cubes. So 8 is 2 times 2 times 2. 27 is 3 times 3 times 3. Knowing your cubes lets you use this formula easily. So you just look at it and you say, okay, 8 is 2 cubed, z cubed, minus 27, which is 3 cubed. And then you're going to go 2z cubed plus 2z times 3 plus 3 squared. So a little bit of cleanup, always involved in cubics. That's 4z squared plus 6z plus 9. I have to factor the common factor out. So they both have a 2 in common. I'm going to factor the 2 out. Leaves me with r cubed minus 1,000. 1,000 is 10 cubed. So I have 2r minus 10 times r squared plus 10r plus 100. I have 5 minus 2x times 25 plus 10x plus 4x squared. You're just looking at them and applying the pattern. Same way with the sum of two cubes. Difference is you have a plus in between, and you can factor the sum of two cubes, where you can't factor the sum of two squares. So you have to be very careful in your mind at firming this idea up. Plugging in for our sum of two cubes, we have 3x quantity cubed. We have 4y squared. There we go. So we have 9x squared minus 12xy squared plus 16y to the fourth. We have m plus 6 times m squared plus 6m plus 36, except I screwed my sign up. This is the plus formula, so that's a minus. You have to memorize these two ways of factoring. The sum of two cubes and the difference of two cubes formulas lets you do these when you have to. There was a question on the IB test where you had to use the difference of two cubes. They don't give you that formula in your formula booklet. They expect you to know. See you on page 5.